Hi everyone, my name is Bryan.
Hi, I'm Adithya.
I'm Angela.
I'm Roshni.
And I'm Yili.
And today we're going to present our project, GoodGrocer. So the main motivation of our app comes behind the idea that sometimes we just need one or two items from the grocery store, but it may not be worth it to go to the grocery store for just one item. Additionally, using an app like Instacart for just one item might not be worth it due to all the fees associated with the app. So our app connects community members by allowing them to submit small grocery requests within their communities. And on the flip side, it lets them fulfill small grocery requests within their communities.
So we're just going to do a quick app demo and we'll get right back to the slides. So let's say I want to sign up for this app. So I can put in my email, my password, my name, and my phone number to get started. Next, I put in my address. And I can also set a profile picture. And now, after waiting for a few seconds, I've successfully signed up for an account. So I can join a community by clicking on Join More and click on Kelton, for example. Now I've joined Kelton. Here I can see all the requests in my community, and I can make a new request. Here I want to choose from Ralph's, and let's say I want some eggs. So I can say I want some eggs. I want a dozen eggs, so I set the quantity as 12, and I want a preferred brand of Kroger. I can also set a picture, and I can add the item to my request. Let's say I also want one more thing. Let me get some chicken. I can click on chicken. So the quantity type is pounds. I just want 1 pound of chicken. And I don't want any preferred brands. And for the notes, I want to say, make sure it's organic. Click on add item, and I can complete my order, and it'll be ready and available. Now let's say Bryan wants to complete my order. He can log into the app and clicks on login, and he can now create a community if he wants to. So here he's clicking on Veteran Avenue to create a new community. He's setting the community address as 640 Veteran Avenue. And then when he clicks on add stores, he can find all the stores around 640 Veteran. And now, let's say you want to complete some requests in the Kelton Avenue group. So you can click on Adithya's, Roshni's, and Yili's request and creates an errand out of it. And now you can see on Adithya's phone, he's gotten a new message that says his request has been accepted by Bryan. Now on Bryan's phone, he can click on every single request and click on either found or not found to let the user know whether he's found that person's item or not. When he completes the errand, Adithya will get a notification on his phone informing him that Bryan has completed his request. So this is the application landscape for our backend. We decided to go with a monolith because it was good for development on a tight schedule, and everyone on the team was very familiar with it. Plus, it's easy to deploy to. We use AWS for our backend, so we decided to use Route 53 as our load balancer. We hosted our entire backend on a Kubernetes cluster, so we use AWS EKS. Each server instance ran on a machine for EC2. We used RDS for our database, and we stored all our built images on ECR, which our developers could push to very easily.
So our application structure, we used a layered architecture. This is because it works well with monolith architecture, and it also has been used by our members of our team previously, so it's easy to kind of ramp up on. So we had 4 different layers. So first, the presentation layer, which was our UI interface with React Native, then the business layer, which contained our business logic, and our persistence layer, which is where it kind of interfaced between the business and database layer to get the data. And then in the database layer, we had a Postgres database for the majority of our data on the app, and then Google Maps to retrieve locations for things like stores and communities.
So for the user interface, you went with the MVC model, so model view controller. The reason we went with this is because it's simple to use and all of our team members had familiarity with it. So for the view, we made use of React Native because it provided all the tools for our purposes, and our team members had all used it previously. It also makes it really easy to control data flow between the different components. So React Native is basically the one that presents the component screens and the interactive elements of our app. And then for the controller, we use React Native along with Redux. So React Native exposes the API to modify the view, and Redux exposes the API to modify the model. And finally, for the controller, for the model, we used Redux as well.
So for the design choices, we decided to use the facade pattern and the abstract factory method. With the facade pattern, we decided to use it specifically for the login process, and the abstract factory method was used throughout our app with the use of components in React Native. This allowed for the users to simplify the design and understand it better.
So for the implementation on the front end, we use React Native as our framework, which is, we wrote the code through JavaScript, and it was built and distributed through Expo. And some of the libraries that we used were Redux for storage, React Navigation for navigation, and then Axios for API calls. And on the back end, we use Golang as our language and deployed this code through AWS EKS. And some of the libraries that we use include SQL-C for interfacing between Golang and SQL, and then Gin for API calls, Pastio for token stuff, and then Viper for like configuration. And then the database that we chose to use was PostgreSQL. And then our testing strategies for the front end were mainly component and screen testing through Jest. So this involved like going through the screens and making sure that things like text input and button logic were correctly and were shown. And then we also did manual system testing where we tested flows in the app, such as like error creation. And on the back end, we did API testing in Golang. So we wrote a test suite for each API, and we examined the test coverage line by line through a VS Code like extension for Golang, which showed us the areas that we like the edge cases that we needed to cover for each API.
So for our CI/CD process, we decided to go with GitHub Actions because it integrated really well with our repository and code. So we had two main workflows, our deploy workflow and our CI workflow. Our deploy workflow basically built and deployed our backend image. So the image on the left, which is our deploy workflow, the first thing you can see is we would detect changes to make sure the changes made in the new PR that we're trying to deploy would be backend related. And if it was, we would set up AWS, build our image, upload it to our ECR repository, and then deploy our changes onto Kubernetes. For our CI workflow, we would have two different steps, two different jobs to run unit tests for both backend and the front end. And once again, we would make sure that the code bases for each one changed in order to run those tests.
So for the Scrum process, we had weekly sprints and weekly meetings for both sprint planning and sprint review. In total, we had 6 sprints in the end, 121 tickets and 20 tickets per sprint.
So in terms of the contributions of each member, so Adithya and Yili worked mainly on backend, and then me, Angela, and Bryan worked on front end. So for the backend, Adithya worked largely on infrastructure, and Yili worked on creating the APIs. And then for the front end, I worked on the app designs, the initial organization, and all the community-related screens. Angela also worked on the app designs, some of the components, and the creating the request screen. And Bryan also made several of the components, as well as the authentication flow.
Yeah, so in terms of our lessons learned, one important lesson was how to track Scrum processes on GitHub, collaborating and spreading work out over time. And then also, of course, we all picked up technical skills within our chosen tech stack and role. For future work on our app for improvement, we definitely want to work on implementing an in-app chat and payment system, an incentive system to incentivize people to shop for their neighbors. There's always room for design improvements. And for backend, we want to work on automatically scaling backend services with demand.